the trig ratios. So, have you ever noticed on a calculator, there's the fancy calculators, there's these 3 buttons, sin, cos, and tan?
Yeah.
Guess what? You're finally going to use these buttons. And, by the way, it's not sin, it's actually sine. It's not cos, it's cosine. And tan, we do say tan, but it's tangent. So these are just short for those 3 words. Well, what the heck are those 3 words? Sabi, I have no idea. This is so confusing. Don't worry. I'm going to teach you right now. So there are 3 trig ratios that we're going to look at. So there are the sine, which is equal to the opposite side over the hypotenuse. So here's what I'm talking about. If you have a right triangle, okay, so here's any old right triangle, and I label the sides A, B, and C. Let's say C was, if it was one of my special right triangles, so if it was a 30, 60, 90 or a 45, 45, 90, I could find the other pieces, no big deal. But what happens when it's not a special right triangle? What if angle C was something like, I don't know, 27 degrees? Like it's nothing, it's not one of my special ones. Well, turns out that every single right triangle that has an angle of 27, if I take its opposite side, so opposite of that angle, wouldn't that be side BA? And I divide it by the hypotenuse, it's going to come out to be the same exact decimal every time. So if I took a 27, so it doesn't matter. Like I could have this right triangle and I could have a bigger right triangle that still had a 27 degree angle. It'd be similar, right? Those 2 triangles would be similar to each other. And so doesn't it make sense that if I took this length and I divided by the hypotenuse, whether it was this triangle or a enlarged version of this triangle or a shrunk down version, that ratio would be the same, right? Does that make sense that it would be? Okay. So the sine of an angle is just equal to that. Whatever the opposite side is divided by the hypotenuse. I have no idea what the sine of a 27 degree angle is. I have no idea. It's just some decimal. You are never going to be expected to know it. That's why there's the buttons on the calculator. So actually, I can tell you. My calculator will tell me what, if I hit sine 27, that means that this side, whatever it is, divided by this side, whatever it is, will always be 0.4539, blah, 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 blah. Always. So normally when we're dealing with these decimals, we go out 4 places. So we would count out 4 decimal places and stop there. You're not going to go on forever, okay? Similarly, if this had been like a 36 degree angle, well, the sine of a 36 degree angle, it's still going to be this side divided by the hypotenuse, but it would have its own decimal equivalent. So if it happened to have been a 36 degree angle, the sine would have been that. It's equal to this side of the triangle divided by the hypotenuse. You'll see. Give me a few minutes. Yes.
So what is the ratio of just the hypotenuse or of that whole triangle?
It's the ratio of the length of this side to the length of the hypotenuse. Okay? All right. So, there are 3 ratios altogether. The next one is cosine. Cosine of an angle is just, special delivery. So, cosine is the adjacent side compared to the hypotenuse. Okay, is everybody paying attention to me? Because you're going to be lost if you're not. Okay, good. So the adjacent side divided by the hypotenuse. Now, what's the adjacent side? Well, if I'm still looking at that 27 degree angle, there are 2 sides that make up this angle, right? AC and BC. Well, BC is already the hypotenuse. The hypotenuse is always the hypotenuse. So AC is what we're going to refer to as the adjacent side. So it's, remember what the word adjacent means. Right next to, yeah. So it's the side right next to my angle. So in this case, I have an opposite side. I have an adjacent side. And I always have the hypotenuse. Okay? And then the third one is tangent. And that is just the ratio between the opposite side and the adjacent side. Of course not. So, let's do one. Let's say I had a right triangle. And let's just make it easy. Let's make it a 3, 4, 5 right triangle. And I have angles A, B, and C. Okay? Now, in this scenario, I have no idea what angles A, B, and C are. Well, I know what A is because 90. But I don't know what B and C are. I have no idea. If I wanted to find the sine of angle C, that's how we would write it, first of all. So when you abbreviate sine, we drop off the E and we just use the first 3 letters. And then I put whatever angle I want to find the sine of right next to it. So according to what we just said here, the sine of an angle is equal to the opposite side divided by the hypotenuse. So if I'm looking at angle C, what side is opposite angle C? Yeah, the side marked 3, which is BA, and then I would divide that by the hypotenuse, which is 5. So next week, I'm going to show you how to turn that. If you have this information, you can figure out what angle C is. We just don't have time right now, so I'll just hold on to that for next week. But I'll be able to figure out what angle C actually is. So what if I wanted the cosine of C? Right, that would be 4 over 5 because it's the adjacent side over the hypotenuse. And how about the tangent of angle C?
That would be 3 over 4.
Correct, 3 over 4, opposite over adjacent. Now, Miss Savia, how in the world am I supposed to remember all this? Guys? That magic word that I mentioned before, yes. So here's how it works. The first, we have 3 chunks, right? So there's sine, cosine, tangent.
That's actually so good.
And then it just tells you sine is opposite over hypotenuse. Just like we had up here, right? Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So it is a magic word that helps you recreate these 3 ratios. Okay? So yes, you do need to know it, but with the magic word, it makes it so easy to just sort of pop it back in. Just make sure you spell it right.
That makes me happy.
Yes, it's really fun. And I think next week when we kind of get into using it, it's fun to do, I think. So let's try sticking with the same example. It matters what angle I'm talking about. So let's say I wanted the sine of angle B now. What would the sine of angle B be? So you got to think what's opposite to angle B. The hypotenuse is never going to change, but the opposite and the adjacent, yeah, in this case it's going to be 4 over 5. Do you follow that? Because here's angle B, so opposite is now 4 over hypotenuse, which is 5. The cosine of angle B, 3 over 5. And the tangent of B, opposite over adjacent, 4 over 3 would be correct. So you will notice some similarities about these things. The tangents are always reciprocals of each other. And then these kind of swap over here. Now, Miss Savia, what about angle A? We never bother with sine, cosine, or tangent of the right angle because now everything, well, it kind of breaks here, right? Because now, who's adjacent? Now you really have two sides, and then your opposite side is the hypotenuse. So we're never going to ask you about sine, cosine, or tangent of the right angle. Just the other two. Okay? So let me give you another triangle. You fill in the three pieces, and then we'll try something else. So, say I gave you this, and I told you that this was, oh gosh, how about 10 root 3, and this was 4, and here's A, B, and C, and I want you to fill in all of these. Sine of B, cosine of B, tangent of B, and then the same thing for C. Okay, take a minute, fill in those 6 things for me. What are you going to have to do first? You got to find AC first. And this is not a special rate, so we don't just know it. You got to do math. Oh. Does everybody have an answer for AC? Yes, I have 2 root 71. C squared gets you 300. A squared gets you 16. So take 16 off of 300, you get 284. And then you need the square root of that, which simplifies to be 2 root 71. So now I have all the pieces. I should be able to find sine, cosine, tangent. All done?
I guess.
Okay. Yeah, you can put it right in there. Are you guys getting what I'm getting?
I could not tell you.
4 over 10. Oh, why am I dopey? I'm going through all this extra effort when they just swap. And this is just the reciprocal. Always! Oh, yeah, but look, once you do it one time, remember the pattern over here. You don't have to do it again. They flip-flop, and this is just the reciprocal. Yeah.
What does cosine C say? For you, 2b over 15?
Which one? Where are you?
The cosine C.
2 root 3 over 15.
The other one. Cosine. Cosine, see.
Square root of 213 over 15.
Oh, okay.
Same as that one. Yep. What's 71 times 2? 142? Oh, that was dumb. There's my answers. So, next week, we'll pick up on this. And okay, let me stop this.